In this video, we will be continuing discussing multiplication and division, specifically about the distributive property and the FOIL method. The distributive property basically says that if you have something in parentheses, such as this x squared plus x, and you have something outside of those parentheses multiplied by it, that you can take this and just distribute it to all of the terms inside. Therefore, 3 times x squared plus x just equals 3x squared plus 3x. You can also think of it as adding 3 of these. So you have x squared plus x plus another x squared plus x plus another x squared plus x. And if you combine the like terms in this expression, you see that you get 3x squareds and 3x's. And that's what makes the distributive property work. This rule of the distributive property can be generalized as a times x plus y times z equals ax plus ay plus az. Let's say we have 3x times x plus 1. How would we use the distributive property here? Well, we're taking this whole term and distributing it to each of the individual terms on the inside. So if we multiply 3x by x, we get 3x squared. And 3x times 1 gives us 3x. And that provides us our final answer. What if we have a problem where our terms are made up of multiple variables, such as 3x times xy plus y? How do we resolve this? Well, 3x times xy would give us 3x squared y. And then 3x times y would give us 3xy. So the distributive property as a basic concept is fairly simple. But what if the thing that you're multiplying by isn't just a single term? What if you are multiplying two polynomials? Well, if you have two polynomials that are each made up of just two terms, then there is an easy method, and that method is the FOIL method. The FOIL method, which again only works for multiplying polynomials that each have two terms in them, is an acronym where the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. And what this means is the first terms in each of our polynomials. So first is referring to this x and this x. The outer refers to this x and this negative 1. The inner refers to this plus 1 and this x. And the last refers to plus 1 and minus 1. And what these are telling us to do is multiply. So the first step of using the FOIL method is to multiply the first terms in each polynomial. So x times x is x squared. Put a plus in. Our next step is to multiply the outer terms, which are x and -1. So we get negative x. Positive x times -1 is negative x. We then multiply the inner terms, +1 and x, which gives us plus x. And then finally, we multiply the last terms, +1 and -1, which gives us -1. And then from here, we simplify by combining those two like terms. A negative x and a positive x are 0, and we are left with x squared minus 1 as our final answer. And this FOIL method is basically just another version of the distributive property. Now, just for fun, let's try a polynomial where, let's try multiplying two polynomials where one of them has 3 terms instead of just 2. So let's try x plus 1 times x squared plus 2x minus 1. So how would we go about solving this one? Well, according to the distributive property, we would take this term that we're multiplying by and apply it to all of the inside terms. Okay, let's do that. So we'll get an x squared times an x plus 1. We'll get a 2x times an x plus 1. And then we'll get a -1 times an x plus 1. Okay. What do we do next? We do the distributive property again with each of these. On this last term, we are taking an invisible -1 and applying it to each of these terms on the inside here. So what we get is an x cubed plus an x squared plus a 2x squared plus 2x, and then a -1 times an x is a -x. -1 times a +1 is -1. And from here, we can combine our like terms. We have a positive x squared here, and a plus 2x squared here. We have a positive 2x here, and a -x here. So this can simplify to x cubed plus 3x squared plus x minus 1. And we have just successfully used the distributive property to multiply these two polynomials together.